Hello and a warm welcome to everyone joining us today. I hope you're having a wonderful day so far. Today we will discuss the networking and cybersecurity demands in the enterprise network and how DDI solutions can optimize their network infrastructure. In this webinar, we'll explore the perspectives of DDI solutions on digital transformation towards the modern dynamic environment. We will also deep dive into how DDI solutions benefit your organization by providing scalability, centralized and integral view, and enhanced security when implemented with policy-driven management and automation. Very quick introduction. I'm your host, Vikram Aditya, product expert from ManageEngine. I collaborate closely with the marketing teams of ManageEngine, DDI Central, and Cloud DNS. A big part of what I do is talk about critical network services like DNS, DHCP, and IPAM. I'm here to share insights on how DDI solutions can significantly enhance enterprise network infrastructures. Now, as for the agenda today, firstly, we will have an in-depth view of cyber threats and networking issues in the enterprise networks. We'll then go through the modern networking demands of the enterprise networks when they are looking forward to digital transformation and the major networking challenges they face and adapting digital tools. Next up, we'll discuss about how scalability and availability is enabled in your enterprise network with the help of DDI solution. Then we will see the importance of network segmentation for enhancing your enterprise network security and how it benefits your network service when implemented. Moving on, we'll explore how policy-driven automation and management enhances your network operations effectively across the networks. After that, we'll talk about how the real-time analytics feature of DDI solutions help in maintaining the security and efficiency by ensuring optimization of the records. We'll then cover the essentials of DNS security and how to implement multi-layered strategies to protect your enterprise network. Cyber attacks are faced by many enterprises when implementing digital tools in the network infrastructure for adapting to the transforming network environment. This approach makes the organization's network vulnerable to external attacks, meaning attackers can gain access to confidential data due to the lack of security and policy. Enterprise networks need to implement cybersecurity for improving the security of the network services from cyber attacks. Let me give you a brief explanation on the most common cyber attack, that is ransomware attack. It is the most common and it costs the highest for many organizations to recover. Almost 56% of the organizations with revenue between $10 to $50 million were hit by a ransomware attack, and that number increased to 72% among companies making $5 billion or more per year. The average payout increased dramatically year to year from $800K in 2022 to $1.5 billion in 2023, and 84% of the private sector organizations hit by ransomware said that the attack has caused them to lose revenue as a result of lost business opportunities. Now, as you see in this graph, the percentage of organizations who paid to get their data back increased gradually. Up to 55% of the organizations whose revenue is more than $5 billion decided to pay the ransom. The smaller organizations choose to use their backup to get their data back as they have a less complex IT network, which makes it easier to create backups. Whereas for the larger organizations, they choose to buy their way out as they possess a complex IT network, which makes it harder to create backups as it changes dynamically from time to time. Now, in order to reduce the chances of paying ransom, enterprise networks need to strengthen the defense of their network infrastructure. Let's now focus on the demands of the modern enterprise network, which are crucial to ensure efficient, secure, and scalable operations when adapting to digital transformation. There are 7 key demands that the enterprise networks need to address for an effective network management. A requirement for a unified system that provides administrators with a single interface to configure, monitor, and manage network devices and settings across an entire organization. A platform that could simplify troubleshooting and updates by providing a centralized point of control. Implementing robust security measures and following regulatory standards protects sensitive data and ensures legal compliance, fostering corporate trust. Strong security and compliance infrastructure build customer and partner confidence in the company's reliability and trust. Establishing reliable and secure communication channels between geographically dispersed locations ensures seamless collaboration and data sharing. This connectivity is very essential for unified business operations, enabling centralized control and resource sharing. Organizing and managing IP addresses systematically ensures that devices can be easily identified and managed within the network. Complete visibility into the network allows for effective monitoring, troubleshooting, and capacity planning. Continuous observation of data flows within the network enables the identification of malicious intruders and optimization of traffic routing. It also aids in detecting security issues such as security breaches or network failures for prompt resolution. Strategies and technologies that support seamless collaboration and access to resources for employees regardless of location. Balancing the needs of in-office and remote workers involve maintaining consistent security policies and ensuring adequate support and communication channels. So these are the challenges need to be addressed with the right IT solution, which benefits in building a secure and effective network infrastructure and also streamlining the network service for every organization to support their growth and development. This image is a holistic representation of how multiple branch houses and headquarters in the enterprise are being connected using private WAN network backbone. This network consists of multiple VLANs, LANs, private and public cloud infrastructures, and data centers to link their private WAN. When enterprise networks are adapting to a digital network solution, they will find it difficult to administrate an integrated network infrastructure and also to safeguard network resources. As you can see, the network centralizes and connects several branch houses, enabling employees to connect with the enterprise network from their remote location. This involves a higher performance private WAN serving as the backbone. The backbone is often established using dedicated IP MPLS routes or an optical core that interconnects all parts of the network with transmission devices, while the branches connected to it are connected via SD-WAN, SDN, or IP MPLS augmented via VPN. Remote workers can access the private WAN network through the public internet through the security gateway. Data centers and cloud data centers are connected with the private WAN through branch houses. The image you see represents how the single branch network looks like. And as you can see, both the DNS and DHCP servers are managed individually. When an organization manages all of its DNS and DHCP clusters separately, the network administrators would find it difficult to implement policies or troubleshoot issues or even updating their resources. The main challenge faced by the network infrastructure is the converging of the whole enterprise network under a common IP infrastructure. Now, how do we achieve IP convergence here? A network infrastructure like this needs a convergent solution like DDI. Let's see what it is. DDI is a specialized network management solution that provides a centralized monitoring and administrating console for the 3 core network services, that is DNS, DHCP, and IPAM. It enables you to take complete control and gain a holistic view into the configurations and activities of those services. With the DDI solution, you can easily define and manage scopes, dynamically assign IP address to hosts, set up custom DHCP fingerprinting policies, manage DNS zones, views, and records, set up DNS security policies, analyze DNS query traffic, review audit logs, manage dual stack IP address inventories of your network, all from a single window. Now, ManageEngine has its own DDI solution, which is called the ManageEngine DDI Central. It is a user-friendly, specialized solution that unifies DNS, DHCP, and IPAM into a single platform for improving operational efficiency and network stability. It manages your existing Linux-based IEC by 9 and IEC DHCP installations and can also set up new clusters. It also manages your Microsoft Windows DNS and DHCP clusters. Throughout this webinar, you'll see its tools and features being highlighted to witness a DDI solution in action. With DDI Central implemented in your network, each branch houses can be connected and managed from a single interface, helping network admins gaining complete visibility over the entire private WAN network. That is, remote employees and clients connecting to the network. Implementing policies and configurations will be much easier for all the devices in the network. To add it up, DDI solution, being a one-window solution, acts as a single point of administration for the entire different enterprise network. With DDI, you can manage the DNS, DHCP, and IPAM services and their configurations to the remote branch house connected with the main enterprise network with technologies like SD-WAN, IP MPLS core via VPN, or even dark fiber cables. As you onboard all your DNS and DHCP servers of a branch host as a cluster into DDI Central, it immediately starts discovering all the configurations in smaller divisions to firm them, thus facilitating a clear visibility. With all the configurations organized in its UI, you can easily control your core services and take necessary actions. Analyze the visual analytics that accompany each module to get quick visual snapshots to arrive at valuable and actionable insights that guides you with quick troubleshooting. With this approach, the enterprise network administrators can holistically view and centrally manage the core network services of different remote branch houses and data centers associated with the enterprise network, all from a single window. DDI Central's centralized platform offers an efficient solution for managing networks across enterprise network by treating each on-premise facility as a separate cluster with its own internalized IP address management. Platform allows for seamless integration of DNS and DHCP servers for each branch houses and data centers added individually to the respective clusters. With the unified interface, users can easily discover, configure, and manage network settings across all locations. Additionally, the platform provides robust monitoring tools to ensure that the health and performance of critical core services and offering a comprehensive and streamlined approach to network management across the enterprise network and environments. Now let's focus on the crucial defensive strategy in network management, network segmentation. This adds another layer of protection, splitting the enterprise network into manageable and secure segments to reduce the attack space, limit data exfiltration, and reduce the scope of audits and compliance. Network admins can separate servers and endpoint devices based on the network they belong to. The implementation of network segmentation involves safeguarding the enterprise network devices from the incoming cyber attacks and meeting network-specific regulations by separating sensitive data into different segments, creating boundaries between the departments and around the external attacks. Segmentation provides detailed visibility into each segment, its inventories, objectives, and policies in the form of DHCP options and tighter control over the configurations. This granularity is critical for identifying and responding to suspicious activities quickly. Network segmentation guides your network admins where to look at in an event of incident or capacity exhaustion. In an event of a security breach, segmentation helps contain the impact of limited area, preventing the spread of harmful effects across the entire network. Advanced scope monitoring with defined segments provide network admins with a visual breakdown of IP addresses within the scope based on their availability status, capacity thresholds, ensuring effective capacity planning and resource optimization. Custom policies for address pools within the subnet allows for specific security and access policies tailored to the needs of different host groups within the same department, thus enhancing both security and operational efficiency. Segmentation also offers flexible configuration options for each scope, which means networks can be tailored to meet specific functional requirements or regulatory compliance needs. By grouping different subnets into shared networks, we can club multiple non-consecutive and unrelated scopes and treat them as a single entity to apply custom policies collectively. You can reduce the scope of compliance by reporting the audits of only those segments to the regulators instead of the whole network. The enterprise network will have multiple devices and machines to be operated and moderated by manually or automation. For that, IP leasing is very important. In order to prevent network overlapping and IP conflict, multiple devices in the network will be segmented to different individual sections. And this process is called network segmentation. This segmentation can be easily done with what's called DHCP Scope Manager in DDI Central, where administrators can segment, organize in hierarchy, and combine into one large network. Let's see how segmentation is done in DHCP DNS DDI Central. In DDI Central, you can create subnets with a specific pool range for specific devices and machines in your enterprise network, like BYOD devices, printers, cameras, routers, POS systems, VoIP phones, etc., which helps in segmenting different departments without overlapping. You can also create static subnets of different pool ranges to ensure leasing is done for specific defined devices and prevent DHCP from leasing for general uses. This is a way of separating from other subnets and providing a specific purpose for leasing. You can add different subnets with different pool ranges into a single supernet for administrators to organize multiple subnets in a hierarchical method for an easy visual breakdown. Admins can combine multiple different subnets and define configurations with DHCP options or custom options with the help of shared network. You can categorize certain subnets to be under a VLAN and describe their purpose. You can assign fixed IPs for critical devices with the help of DHCP host reservation. It's important to note that SuperNet and VLAN helps in organizing subnets to make administration process simplified, and there won't be any configurations available for both of them. When the configured subnets are viewed under the IPAM module in DDI Central, the entire IP address inventory within that particular subnet is listed. As we delve deeper into a specific subnet in IPAM, a donut plot provides a visual breakdown of the number of IP addresses in the subnet according to their availability status. These visual snapshots assist administrators with effective capacity planning and alert them at utilization thresholds. In an event of an IP conflict within a particular subnet, the admin can click on any available or free IP and directly assign it as a fixed address to one of the conflicting hosts until a subsequent remediation. This way, admins can have a hands-on control over the IP address inventory within a subnet. On this slide, we have a simplified example of how network segmentation is achieved using DNS domain views. We'll talk through the process step by step. highlighting the distinction between internal and external views for zones under the domain name zilkerenterprises.com. So let's see what are DNS views first. DNS views is a special feature through which you can implement network segmentation using DNS domain views. It enhances protection against potential threats by customizing DNS responses, enforcing distinct security policies, and control access for different groups and network segments within your enterprise network. Let's say a client is sending a query for the domain name zilkerenterprises.com. Now, this request is sent to the DNS server to resolve for the domain name into an IP address. On receiving the query, the DNS server first checks the client's IP against the internal view match list. This list contains only IP addresses of registered employees in the enterprise. Since the client's IP is not internal view, the DNS server then checks the external view list. And this list has no IP restrictions and resolves queries for any client IP. This view is used to provide a version of zilkerenterprises.com that only offers a generic information to external visitors inquiring about Zilker Enterprises. The DNS server confirms that the query for zilkerenterprises.com should be handled under the external view. It locates the requested zone under the domain name zilkerenterprises.com and directs the client to the appropriate source. The IP address returned by the external view is different from the internal one, ensuring that only public and non-sensitive information is accessed. Finally, the DNS server sends the appropriate response back to the client, and the client then proceeds to access the resource. You can analyze the queries to the views configured along with the hosted and non-hosted domains. Alongside, you can have a visual breakdown over the number of queries to the views and domains for custom time interval and the number of queries received per IP with the help of domain query analytics. To evaluate a domain thoroughly or a view's performance, select a specific domain or view from a list. This will display the domain-specific performance metrics, including hourly query load over a user-defined time frame. You'll also see details for IP addresses leased under this domain, such as lease duration, MAC addresses identifying each host, and the vendors of the host machines. Additionally, the total query load across all IPs, as well as individual query loads, are visually represented in a donut chart, accessible by selecting the respective IP. Furthermore, a separate donut chart provides a visual breakdown of the query volume for different types of DNS records. Clicking on a record type such as A or Quad A will display a comprehensive list of all the zones queried for that specific record type. This list includes the key performance indicators such as hourly query load, queries per second, and the total number of queries covering the zones associated with the selected record type. Additionally, you can select a specific zone within the record type to drill down and view a visual summary of the query analytics about that zone's records. DDI Central will continuously log all the actions done and changes made in the DNS zones, records, and views, while also in DHCP scopes for providing insights to admins to ensure no external alterations made to the confidential data in compliance with PCI DSS, GDPR, and more. Let's see how DDI Central implements auto failover setups for DNS and DHCP services. In DDI Central, for the DHCP servers, while configuring a subnet, you can add one primary and add as many secondary servers. In case the primary DHCP server fails, the secondary server comes to the fore and handles the traffic. If you want these servers to split the load, you can enter the relevant value in the split field. A value of 128 here indicates 50-50 load balancing actively involving both primary and secondary servers to handle the DHCP traffic. For the DNS servers, while configuring a domain, you can add multiple primary DNS servers for the domain. Subsequently, DDI Central allows a list of multiple secondary servers to facilitate reliable access to resources across the enterprise network. The DDI solution in place, data from all these three core services are not only collected, but also correlated and analyzed in one central hub. In a DDI solution like DDI Central, IPAM serves as a centralized and contextualized network source of truth that maps upstream relationships among the core services. As you can see in this image, behind the lease history of a particular IP, you get to see how it has been captured and correlated rich IP metadata like DNS records, DHCP lease information, and IP address allocations for various hosts within the network. This unified approach allows for a holistic view of network operations, enabling enterprise network admins to make timely and informed decisions based on the comprehensive data analysis. This information aids in quickly troubleshooting network issues, optimizing resource allocation, and maintaining network stability. With these three core services integrated, DDI serves as a sophisticated automation hub as it becomes easy to set up end-to-end automation involving these services. So here are some of the key processes that can be automated using a DDI solution. Using DHCP server, you can automatically assign IP addresses to hosts on the network. This enhances the efficiency of network resource management and ensures that IP addresses are utilized appropriately, reducing outage or IP address exhaustion. The dynamic DNS feature updates the DNS records automatically when an IP address changes, ensuring that the network resources are always accessible via their host names. This is crucial in branch host settings where device mobility and configuration changes are frequent, necessitating real-time updates. DDI systems automatically detect and resolve IP conflicts and maintain an updated IP address inventory, ensuring reliable connectivity and preventing downtime in network operations. Scheduled creation of DHCP scopes and DNS records allow network admins to go on schedule it and forget it mode, enabling them to plan and implement network expansions or updates at predetermined times for maintaining uninterrupted service during operational hours. Scheduled DNS or DHCP report from time to time gives admins a real-time snapshots of subnet capacities and zone query analytics for strategic resource planning of resources. DDI solutions offer built-in automated failover setups for DNS and DHCP services, guaranteeing business continuity in an event of infrastructure failure in enterprise networks. DDI Central's DNS query resolution policies for Windows Microsoft servers help in configuring query responses and redirecting queries to specific network segments based on the criteria such as time, internal protocol, and transfer protocol. DDI Central's Windows Microsoft enables you to configure DNS response for different applications or services by defining the zone scope and also implement split brain configurations where you can separate responses for both internal and external queries. This helps admins manage the network traffic and segment the responses for different departments of the organization. This also helps in preventing DNS-based attacks. You can configure the QRP in Windows by going into DNS Firewall and selecting DNS QRP option. Here you can create your own QRP by clicking on Add QRP option and provide the details in the fields such as name, criteria, condition for matching and not matching. ManageEngine DDI Central benefits administrators in IoT management with policy-driven automation, where specific configurations are applied to selective devices in the enterprise network. Network admins can create subnets of different IP ranges and allocate them for devices from various departments, and also implement security policies and configurations for even more narrowed down IP allocation. To segregate the IP allocation, you can use VLAN, which isolates the IP request of certain devices from other network segments. This way, Devices like servers, surveillance cameras, printers, and routers who need continuous IP resource allocation can be assigned immediately when connected to the network without interruption, and the IP resources dedicated to them can't be accessed by other department devices. DDI solutions like DDI Central benefits administrators in identifying the device's type and its MAC addresses from the DHCP request for categorizing in a client class with the help of DHCP fingerprinting. You can detect the device's type and classify it to a specific client class by creating a client class and providing the architecture or hardware details. This can be simplified with the template type where you can fill in the fields with details, but when it comes to the IAC format, you have to provide traditional IAC code. This helps in proper IP allocation and device configuration with policies by segregated devices based on their type. Plus, implementing by toggling, you can easily import the values from the pre-boot execution environment Pixie template to a client class to quickly distribute essential boot files based on their device's OS type identification. DNS is the first point of contact across external networks. The DNS firewall constitutes the network's first line of defense. Following a layered approach, it imparts self-defending capabilities to networks by placing strategic defenses against unwanted intrusions. It actively blocks malicious activity using domain blocking and mitigates ongoing attacks with its response rate limiting policies. So let's see how DNS firewall works. DNS firewall's response policy zones, also known as RPZ, in DDI solutions allows you to customize the responses for recognizable domain name by implementing security measures such as blocking malicious domains, redirecting users to safer page, and also applying custom policies. The query sent to the RPZ domains is further analyzed by DDI Central based on the configured RPZ policies. And when it matches the RPC policy, the query will be resolved to a custom IP address. And when it doesn't, it gets blocked and the user gets redirected. You can enable RPC by selecting the domain type when a new domain is created. An RPC can be created in the DNS options section by clicking on Response Policy. The RPC also logs the queries to block domains, providing valuable insights into attempted access to harmful sites and helping to identify patterns of malicious activity. DDI Central enables you to apply a variety of DNS options to RPCs to have a granular control over the clients accessing it. Now let's consider a scenario where an employee in the enterprise has clicked a link with crafty phishing mail and annoyingly gets his or her system infected by malware. Upon connecting to your enterprise network, the malware tries to covertly access malicious sites using your DNS resolver. DDI Central easily manages such situation with its DNS firewall. This firewall maintains a blacklist comprising a recognized collection of undesirable domains. Before the resolver can provide the actual IP address, it checks the domain against this list. If there's a match in the list, the resolver does not proceed to fetch the real IP address from the authoritative DNS server. Instead, the user gets redirected to a safety page. By clicking on the DNS firewall in config section, you can provide the domain name to be blocked, category for blocking, and also the redirection IP to redirect clients to safer page. You can also view the domains blocked and the domains blocked among the subdomains here, and this data can be imported as CSV format. You can also view the blacklist of malicious domains in the View List section with their categories. DDI Central displays the information on who is trying to access the blocked IP address in the network environment. That includes the host name, MAC address, date, and time, which helps the network admins to identify and troubleshoot issues. You can also view the total number of queries received for an IP address, and this visual representation helps identifying and blocking malicious sites. Dissect a common cyber attack scenario involving a botnet and discuss the defensive strategy that can be employed using a DDI solution. At the core, we have the botnet command center targeting a particular victim network in your enterprise network. It keeps sending instructions to compromised endpoints called botnets. These botnets then execute the attack by sending malicious queries to the DNS servers using the IP address of the victim. And this process is known as IP spoofing. The DNS servers in your enterprise network, unaware of the deception, responds to these queries. However, due to the nature of the attack, these are not just simple replies. They are massively amplified, meaning a small query triggers a large amount of responses. The final target of this is the victim network in an enterprise network. The amplified responses flood the victim's device, potentially overwhelming it with data and causing significant disruptions. This type of attack is known as the distributed denial of service or DDoS attack. These threats can be instantly identified using DDI Central's query analytics tool that visually charts unusual spikes in hourly traffic and indicating a DDoS attack in progress. To mitigate the DDoS attacks, DNS servers can be configured to limit the response rate to any individual IP addresses. This way, it prevents the DNS servers from being used as amplifiers in DDoS attacks and further prevent the movement of malware from compromised end-user systems to more sensitive systems and data center resources. The response rate limiting is a DNS security feature that intelligently regulates response throttling to mitigate the impact of DNS amplification attacks, ensuring uninterrupted access for legitimate clients and upholding a well-balanced approach to security. Now let's see how response rate limiting, which is crucial for controlling DNS responses, especially during amplification attacks, is implemented in DDI Central. This feature allows administrators to set various parameters that control different aspects of DNS response behavior. The RRL form that you see on screen does not just limit the number of identical responses per second from single IP or subnet, but also limits the number of all kinds of responses, error responses, DNS responses, specific types of DNS responses per second. You can also define how broadly rate limiting is applied across IP address ranges. It also enables you to specify the trusted clients that are exempt from rate limiting. Response rate limiting can be accessed in ISC bind by selecting rate limit in DNS option, which provides several fields to fill in details like all per second, error per second, prefix length for IPv4 and IPv6, and more. You can also provide the IP of clients you want to exceed from this list in the exempt clients field. Selecting the DNS URL in configuration sections in the Windows Microsoft version, you can able to modify the DNS URL settings by editing the values for your needs. You can also provide the IP of clients you want to exceed from this list in the exempt clients list section. Cyber attackers need to move freely through a network to identify items of value. Network segmentation is critical of an overall cybersecurity strategy that reduces the risks and impacts of attacks during the occurrence of a breach. By segmenting a network into subnets or scopes, you isolate each segment from the rest of the network. Each segment establishes an isolated broadcast domain within the DHCP server. By taking this pragmatic approach, enterprise networks can minimize business disruption and reap benefits such as limited exposure after an intrusion, reductions in lost productivity, and remediation costs and reputational damage from the actual loss of confidential data. Network segmentation is only a part of DDI Solution's layered security philosophy, enabling network to survive intrusions and minimize or even prevent successful data breaches. In the end, this allows for a speedy return to business as usual. Segmenting the scopes into subnets and VLANs help containing the damage by isolating the affected segment, allowing admins to more effectively control the spread and mitigate risks. Subnetting also reduces network-wide threats by quarantining compromised areas and hindering unauthorized lateral movement within the network. Let's say an organization comprises VoIP phones and they need to isolate the particular network segment from the rest of the network infrastructure. Also, a subnet within the IP with an IP range is created for VoIP phones, so specific IP allocation should be done for the VoIP phones. During the allocation, the message request sent by the VoIP phones towards the DHCP server can be interrupted by other messages in the network, causing IP conflicts and network delay. This means VoIP network traffic should be isolated from the other traffic sources within the network infrastructure. DDI solution like ManageEngine DDI Central helps resolving isolation of VoIP phone network traffic using the VLAN feature. VLAN comes into play a crucial role in separating IP allocation for VoIP phones. Admins can create a VLAN for VoIP phones by providing the VLAN ID, VLAN name, and description, and can easily be associated with the subnet created specifically for VoIP phones. VLANs help isolating the broadcast message sent by the VoIP phones to the DHCP server for IP allocation and prevents getting interrupted by other network traffic. Overall, implementing VLANs with the help of ManageEngine DDI Central not only simplifies the management of VoIP specific subnets and IP allocations, but also ensures that network segments remain secure and operationally efficient without intersecting during the allocation process. Let's say an organization has multiple branch houses across different locations, and not every employee can be able to work at the main location. Therefore, the organization needs to facilitate a remote work option for their employees. Now, the organization needs to identify and permit only the employees when trying to connect with the network from their remote location through the public internet, which means that they need to prevent unauthorized individuals from entering the network and accessing the resources. DDI solutions like ManageEngine DDI Central benefits the administrators with identifying the clients from their remote location with DHCP fingerprinting. Network admins can identify employees through their device's MAC address, and they create client classes to classify employees in several segments. In DHCP fingerprinting, admins can also implement security policies in the DHCP fingerprinting to ensure more security and more narrowed permitting into the network. This way, network administrators can only permit employees into their network and also implement work from home facilities for their employees. Now, as we conclude the webinar, let's reflect on how a full stack DDI solution redefines the way we manage enterprise network. At its core, DDI solutions like DDI Central enables seamless communication by assigning unique IP addresses to every device, allowing them to exchange information and the power to connect that drives business forward. This network is the foundation of an enterprise's digital ecosystem, ensuring smooth interactions between devices, applications, and users within the network and across interconnected branch houses. In today's fast-paced and competitive IT landscape, network solutions for managing enterprise networks are essentially for maintaining robust connectivity, enhancing operational efficiency, scaling services, and ensuring enterprises can adapt to evolving business needs. Thank you everyone for joining us in this insightful webinar on how DDI solutions can help in optimizing enterprise networks.